Unity has systems, which are in system groups, which each have rate managers. A system is where most your game logic goes, if not all. It has an onCreate, which is called when the system is first created, an onUpdate, which is called over and over each frame, and an onDestroy, which is called when the system is destroyed. If you put a system in a system group using the UpdateInGroup attribute, it will run after the systems in earlier group and before the systems in later group. Systems have 3 different priority brackets. If you set order first equals true, in UpdateInGroup, it will be set to the earliest bracket and run before all systems that don't have order first equals true. If you set order last equals true, it will run after all systems that don't have order last equals true. And if you set both to true, you will create a black hole that consumes the whole Earth. You can also use the UpdateBefore attribute to make a system run before another system, or the UpdateAfter attribute to make it run after another system. There is also onCreate attributes, which does the same but for creation times. However, you can only do this if they're both in the same system group and have the same priority brackets. So this would not work. You can have as many UpdateBefore and UpdateAfter attributes as you want. System groups are also systems, so you can nest them and order them as you like, as long as this makes it easier for you. Rate managers control how often update is called for a system group and how the systems in it perceive time. It essentially works like this. In the update function of the system group, it calls shouldGroupUpdates, which uses its internal logic to figure out if it should run this frame. And if it should, it pushes the time. If you use systemapi.time, then the elapsed time and delta time you get from that is whatever the system group has pushed. It also sets the group allocators, which are also known as World Update Allocator. If you aren't using World Update Allocator, you really should, because you do not need to deallocate it. After it returns true, it updates all systems and calls shouldGroupUpdate again. Here it again then checks should I update again, and if it returns false, then it finishes updating and goes on its merry way. However, it can also update multiple times in a single frame if needed, or 0 if it returns false on the first call. Unity has 3 default rate managers and also supports not having a rate manager. If it doesn't have a rate manager, it will just update every frame, and the delta time and elapsed time is the same as for the parent group. The fixed rate simple manager also updates every frame, but it reports a fixed delta time. If your game runs at 100 FPS and is set to 50 FPS, it will say that 0.02 milliseconds have passed instead of 0.01. If you've seen all the games, this is kind of how a lot of them work, where they assume the frame rate will be 30 FPS or 60 FPS, and then do all their calculations based on that. This rate manager is unaffected by time.timescale, so no matter what you set the timescale to, this will still report the same fixed delta time. There is also fixed rate catch-up manager, which works like fixed update in regular Unity. If this is set to 50 frames per second and the game runs at 100 frames per second, then this will run every other frame instead. If your game runs at 50 frames per second, but the timescale is 2, this will update twice every frame. It also reports a fixed delta time like the previous one, but the elapsed time will be somewhat close to the elapsed time of the regular system group. There is one caveat though. It has a max limit for how many times it can run in a single frame. This is because if it takes more than 1 frame to run it, then it'll first have to update once, and then it'll have to update twice to catch up, and then it'll have to update 4 times to catch up to that again. So the runaway effect gets really large if you don't cap it. However, Unity's implementation has a tiny bug where it doesn't respect the timescale of the project, meaning if you double the timescale, it can still only run the same maximum amount of times within 1 frame. If this is an issue for you, you can just copy the code from it and write your own. Fixed rate catch-up manager is good for all game logic that shouldn't be frame rate dependent, but still happens on a frame basis. So physics stuff and all the stuff you would use fixed fixed update for in regular Unity. And last up is Variable Rate Manager. If you used unscaled time in regular Unity, this one works the same way. It uses a stopwatch to check how much real time has passed since last time it was called, and then compare that to the frame rate it should run at. And then it reports the elapsed time and delta time as the real time since its last update. So if your game runs at 50 FPS and this is set to 25 FPS, then it'll run approximately every other frame. And if your timescale is 2, it will still run every other frame, and the time it reports will be unaffected by the timescale. Variable Rate Manager is good for slow operations that shouldn't happen every frame, and then don't impact gameplay. For example, if you need to check if there are any dead enemies that have left the screen, you could do that here because it doesn't really matter if they've been off the screen for 1 second or 0.5 seconds. Unity has a lot of default system groups, but the ones you need to care about are these. There is Initialization System Group, which runs every frame before everything, and Presentation System Group, which runs every frame after everything, and usually contains all the logic relevant for rendering. There is also Simulation System Group, which runs every frame, just like Update in regular Unity. Inside Simulation System Group, there is Fixed Step Simulation System Group, which has the Fixed Rate Catch-up Manager set to 50 frames per second. You can consider this the same as Fixed Update in regular Unity. There is also Variable Rate Simulation System Group, which uses the Variable Rate Manager set to 15 FPS. And last is the Late Simulation System Group, which also runs every frame, but runs after all the transform logic has happened. If you don't specify a system group, your system will automatically be placed in Simulation System Group and run after these two system groups and before this one. I would recommend making your own system group that does the same, but specifically updates before the transform system group. I hope this helped. If it did, please like and subscribe, check out other videos, and be on the lookout for the game we're announcing soon.